Today's lesson is on adding and subtracting rational expressions. And before we begin, I want to look at a warm-up where you are adding and subtracting basic fractions. So when you're adding basic fractions, you must always create a common denominator. And creating a common denominator can sometimes mean that you're multiplying each expression by the alternate denominator, and sometimes it might mean that you're only multiplying by part of a denominator. So looking at number 1, we have 1 over 3 plus 3 over x. Looking at these denominators, they don't have anything in common. So I'm going to multiply each expression by the opposite denominator. I'm going to multiply the first expression by the denominator of x. And when you do that, you're multiplying the top and bottom by that denominator. And the second expression, I'm multiplying the top and bottom by 3. By doing this, my first fraction becomes 1 times x, or x, divided by 3 times x, which is 3x. My second fraction becomes 3 times 3, 9, divided by x times 3, or 3x. Once you have a common denominator, you add your numerators. So in order to add these numerators together, we have x plus 9, which we write just like that. Our final answer is x plus 9 divided by the common denominator of 3x. Number 2 is a subtraction problem. We have 5 over 6 minus 5 over 6x. When you're looking at this problem and you look at the denominators, the first expression has a denominator of 6 and the second expression has a denominator of 6x. So if you multiply the first expression by x, both the top and bottom, that's actually going to create your common denominator. You won't have to do anything to the second fraction because you only had to multiply in that single value of x. Our first fraction becomes 5x over 6x, and we're subtracting 5 over 6x. So by multiplying that value of x, you can see that we clearly created a common denominator. And once you create that common denominator, you're just going to subtract the numerators. And subtracting these numerators is going to give me a final solution of 5x minus 5 divided by our common denominator of 6x. And that's how you add or subtract fractions. It's by creating a common denominator and then working with the numerator. So moving on to adding or subtracting a rational expression, there's 5 steps to this. The first step says to factor the denominators, and please pay close attention to these steps as they are all very important. So factor the denominators and determine the lowest common denominator. So what's the smallest denominator you can make with all of the fractions? And you need to make them all the same. Step 2 is to rewrite the expressions with the lowest common denominator. That means you might have to multiply the numerator and the denominator by a certain term, but do whatever you have to do to get the expressions to the common denominator. Then you're going to add or subtract the fractions. But remember from the 2 examples that we just did, adding or subtracting the fractions means that you're adding or subtracting the numerators. The denominator has already been found, and the denominator is the common denominator that you determined in step 1 and 2. Step 4 is to simplify. Simplifying might require you to factor the numerator so that you can eliminate common terms. And step 5 is to divide out common factors. The first example I gave you, I actually already put this with a common denominator just so we could skip over that step and we could see what it's like to add or subtract, in this case add, with a fraction that already has a common denominator. So we don't need to touch those. Once we have a common denominator, the directions say that we now need to add the numerators together. So in this case, I can rewrite my numerator as x squared plus 8 plus 6, and we're going to divide this by x plus 2. I'm going to simplify my numerator, writing this as x squared plus 14 divided by x plus 2. And if you can factor the numerator, you need to check and see if you can do that. In this case, you cannot factor any further, so this here would be your final answer. This one was nice and short. Number 2 is not so short. So we have x over x plus 1 plus 2x minus 1 divided by x squared minus 3x plus 2. So following the directions above, I need to start by factoring my denominators. Of course, my first denominator of x minus 1 cannot be factored, but my second denominator, that can be. X squared minus 3x plus 2 can be factored to x minus 2 times x minus 1. Now I'm going to compare my denominators. So I'm comparing this denominator to this denominator. What can I do to make them the same? So what has to happen to either of these to make them identical? And this one should be simple to see. Both of these denominators have a factor of x minus 1. Now this one has a denominator of x minus 2. So if you multiply the first fraction by a factor of x minus 2, both the top and bottom, you will arrive at the same denominator, or a common denominator. Also, recall that the directions tell you to leave your numerator in standard form. So right now, in order to leave this in standard form, I need to distribute to my numerator, or distribute throughout my numerator. My numerator becomes x squared minus 2x. My denominator can stay in factored form, and I now have x minus 2 times x minus 1. I am adding 2x minus 1 divided by x minus 2 times x minus 1. Here you can see that you now created two of the exact same denominators. So once you have the denominators equivalent or identical, you can add your numerators together. So I'm going to add x squared minus 2x plus 2x minus 1. That gives me x squared. Negative 2x plus 2x is going to be 0 minus 1. And this is over my common denominator of x minus 2 times x minus 1. Now the directions will tell me to factor my numerator if possible, and you want to check to see if you can eliminate any factors. X squared minus 1 factors to x plus 1 times x minus 1. This is over x minus 2 times x minus 1. I have a common factor of x minus 1 that can be eliminated, and my final answer is x plus 1 divided by x plus 2. Okay, if I go back through this problem and just add some extra notes in for you, I'm going to start at the top and just make a note that I am creating a common denominator. And then in the next step, I'm going to write that I need to add my numerators together. So once you create a common denominator, you're going to add your numerators. And in parentheses, I'm just going to put in standard form. You can only add if they are in standard form. After I add my numerators, I'm going to factor my numerator and eliminate common factors. And once you do all of that, you will arrive at the final answer. The next example is subtracting rational expressions, which is the same process, but now you just are subtracting your numerators instead of dividing them. Just like the previous problem, the first step is to factor our denominators. My first denominator factors to x times x minus 2. So there's a GCF of x. My second fraction is x plus 2 divided by 2 times x minus 2. So I can easily see that both denominators have a factor of x minus 2. The first denominator is missing a value of 2, so I'm going to multiply the first expression, both the top and bottom, by 2. The second expression is multiplying part of the denominator of x. When I do that, I do have to make sure I distribute my values throughout my numerators. I actually just realized I wrote something wrong right here. This should be x plus 2. Look at the original. So sorry about that, but fix that to x plus 2. So now when we distribute our numerator, we end up with 2x plus 4 divided by our newly created common denominator of 2x, that would be multiplying in that value of 2, times x minus 2. We are subtracting our distributed numerator as x squared plus 2x divided by our common denominator of 2x times x minus 2. Now you have to pay close attention because when you're subtracting fractions, you're actually subtracting every term in the second set of parentheses. So we have to distribute this subtraction sign to both terms in the second numerator. When I combine my numerators, I now have 2x plus 4. I am subtracting x squared, but I am also subtracting 2x. And we are dividing by our common denominator of 2x times x minus 2. At this point, you have to simplify this numerator by combining like terms. 2x and negative 2x will be eliminated. We're left with a numerator of negative x squared plus 4 divided by 2x times x minus 2. Now, in this numerator, you have to recognize that subtraction sign, or the negative sign, which starts the function. Previously, when we learned about factoring, we learned that you can never have a negative leading coefficient. So I'm going to factor out a negative 1 of that numerator, leaving me with x squared minus 4 divided by 2x times x minus 2. And now at this point, you can factor x squared minus 4, the two factors that multiply to negative 4, and add to 0 are positive 2 and negative 2. So our numerator becomes negative 1 times x plus 2 times x minus 2. divided by the common denominator of 2x times x minus 2. We have one common factor here. We can eliminate x minus 2. By eliminating x minus 2, our final answer is negative 1 times x plus 2 divided by 2x. And I encourage you to leave it in factored form like we talked about yesterday. This here is your final answer.